Oh, look, he's only 10% of me. Hello, my name is Pavel Serenkov. Welcome to a new Cube video, and today I will show you how to use different display modes in CubeGUI. Let's do it. So we are back to our terminal, and today I would like to demonstrate you such feature as a display mode in the CubeGUI, and we can take a look how it is useful. So we start the cube and we open some example cube file like this one, for example, and gets the standard view with our dimensions, metric dimension, call tree, and system tree. And the feature which we are talking about is one finds above this dimension. So it's this drop down menu, this drop down menu, and this drop down menu. As default, one usually finds out is this absolute as a setting. What does it mean? With this drop-down menu, one defines what kind of value GUI displays. What does it mean? So in absolute mode, the GUI displays exactly the data which is stored in a cube file, maybe aggregated, maybe calculated, but that is the data. If we take a look at, for example, drop-down menu in metric tree, one can see instead of the direct data, the percentage. So the basically the ratio of the value in some element with respect to another one, and exactly this another one value is then that's what we actually defines here in this drop-down. Okay, let's take a look what do we have. In the metric tree we can we have own root percent and external percent. In the call tree we have own root percent, metric root percent, metric selection percent, and external percent. And in a call in a system tree we have okay, the same own root, metric selection, call root, and call selection. That seems to be similar to the metric root and metric selection. We have also external percent, and we have something unique or special for system tree is the peer percent and peer distribution. So before we go further, here I would mention that this external percent mode is rather a larger feature. Therefore, I will dedicate to it a separate video. Here I would just demonstrate other settings than this external percentage, external percent. Okay, here I would like to remind you, please subscribe and comment if you don't understand something or if you like something, and give us a like, of course. Okay, let's take a look at the this another modes. So if we have a metric hierarchy, for example, we can we have some values, but we can compare those values. So if we choose this own root percent, now first of all we get here only hundreds, because we see all the roots of the in the metric dimension, and they are compared with themselves, so therefore it's 100%. But if one has a metric hierarchy and one expands the metric, and then one sees, okay, the computation, the value which one would have seen here in if one has an absolute mode, that is this 3,924. This is compared to the value of own root. What is own root? It's metric time. So the compared to this value, this is 83%, and the MPI is 16%. So, and that is the simple way how one can estimate a contribution of this value. So but this value means it's always individual, but contribution to the more general definition. So this is computational time, that is 83% of total time. The MPI, that is the 16% of total time. If we take a look, for example, at another metric like this MPI byte transferred, we have there also some submetrics, like for example this one, and we see that this here 10% of bytes were transferred using point-to-point communication, 10% from total transferred bytes, and nearly 90% using the collective operation. And we can, of course, expand it more, so 44%, 45 nearly outgoing and the same amount incoming. So that is the easy way how one can compare the contribution of some subcategory towards the general category. Of course, if we have a metric which doesn't have any submetrics, in this mode the value will be always 100%. The same is valid for example, not remapped cube file. We have now trace CubeX. If we would have scout CubeX or profile CubeX, we wouldn't have a hierarchy of metrics, and then in this mode we will have only 100%. Okay, hopefully that is clear, more or less. Then let's take a look in call tree. So let's now we are seeing absolute values. Let's expand it a little bit, like here. So we have here 6. What is that? 686,000 something visits. Let's go and take a look at computation. So that is 303,000 seconds. That's computation. Computation code has taken 3,000 seconds. Okay. So and then we of course can select, for example, own root percent as the same like it is in a metric tree. So we can compare this value, Monte Carlo IP run DMC, in comparison to the value of main for the very same metric. Yeah. So like we see that this call contributes with 99.7% to the metric to the total the value of total run or of the most general call path, let's say. Yeah. So that is the easy way. Then another thing, metric root percent. So another selection, and if we click and we see that it is 83%. Yeah, and if one compares this 83%, that is the value of Monte Carlo IP run DMC in comparison to the value which is in a metric time on total aggregated value of metric time. So that is basically like a contribution of this value to the most general metric. The metric selection percent compares this value of this call path to the value in metric tree, but from the selected metric directly, not the route, but the metric itself. One would argue that metric selection percent and own root percent are identical. They're identical in this case, but not in definition, let's say. One can have situation that one has multiple roots in a call tree, for example, and in this way, in this case, the metric selection percent will be different than metric the own root, because own root compares with the value of own root, and in metric selection percent one compares with the value of total metric that aggregates or contributes, relates to the whole forest, to the all roots, and therefore it will be different. But in this example it is the same. Okay, and then if we take a look at the system tree, we find out here pretty much the same settings up to the peer. So let's take a closer look. If we expand it a little bit, and then of course we can select own root percent, that would be then the percentage of this value in relation to the top machine. If we go to the metric root percent, then it is compared to the value in a metric tree. Metric selection, that is compared to the value of computation in metric tree. If we select here call root percent, that is behaves the same like with metric tree, just with call tree. So if we select call root %, then this value is the same, like it's compared to the value of the root element in a call tree. In our case, as we see, call root and metric selections are identical. And that is again, the reason for that is because we have here only one call tree. If we would have call forest, then we would have different values, because we would compare it with slightly different elements. And the same call selection, so we basically compare this particular value to the value in selected call tree, call path here. Okay, so these are different, let's say, reference values to our aggregated partner, let's say. And we have two special views, peer % and peer distribution. They are related only to system tree. So if we select a peer %, what happens? The values in call tree, so if we expand them, then they are scaled or mapped into the range from 0 to 100, where 0 is the 0 on 0 element is mapped the actual 0 value, and the maximal value mapped to the 100. That's why we see that here is, for example, we have 100, and nearly all elements are reddish. They are all in the area range between 91, maybe something around of 80, towards the 100. So if we compare the distribution of values in the system tree from 0 to maximum, then we can see where they are distributed. And, this helps us to estimate, let's say, scattering of the values. This is particularly useful if we use plugin statistics, which I will explain in an own video. So here I just demonstrate. Here, for example, if we select the absolute values and go on statistics, we get the bar plot with minimum value, with maximum value. And then if we go to per %, we see that the bar plot is kind of squeezed on top. So we see that the minimal value is 90%, maximal is 100, and everything is in this range. So there is no values which are close to 0. Okay, and that is peer %. It helps to estimate more or less where the so-called load balance metric. If we take another setting, peer distribution, we get a little bit more colors here, and we do again mapping on range 0 to 100, but this time on 0 we map the minimum value. So we basically get a range from 0 to 100, but all the values are scaled on this range. And here we can find the maximal value, here is 100, and we also can find the minimal value, which would be then 0. This rank gets the minimal value. And if we take a look at the box plot, we see that minimal value is here, 0, maximal is here, 100, and that is the range. More information one gets a little bit with violin plot, so one sees more distribution, but that deserves own video. So these are basically settings which one can select in order to compare the values in a corresponding dimension, and they either relate to the neighbor dimension or like in system tree on itself. External case, external percentage is deserves own video, therefore I will skip it here. Another topic which I would mention here, how it behaves with dimension order setting. If one selects, for example, different dimension order, so now we have metric, call tree, and system tree, we can have theoretically like system, metric, and call tree, like this one, where one selects like rank and one has a tool for this rank, the settings of metrics and the call trees. The drop downs are still there. Currently they are visible, but they will be disabled because this call root percent or this metric root percent doesn't have sense, because the display in these settings in the call tree doesn't have value, because we cannot aggregate over the metric tree. So therefore there is no value, and changing here settings also doesn't have any meaning, because we cannot compare no value with anything else. Therefore one should keep it in mind. And the only meaningful setting would be also of course here, like our own percent as usual, or here in the call tree, where we can see then, like for example, metric root percent, and we can see the values. And these values are as a reference value is taking exactly this metric value in the metric tree for that selected MPI rank. So therefore one should keep in mind that as a reference value is not the metric value which is aggregated like in previous case completely over the whole cube, but only for this selection is taken. So that's the thing which I wanted to point out, because one has to keep it in mind. Okay, so I hope you liked this video and understood how this feature is working and for what it is might be useful. If not, post a comment below and give us a like and subscribe. And later on I will explain also how this external percent with external cube is working and how one should interpret it. Okay, see you next time.